Welcome back to All This Math. Wait, my microphone on? Yeah, had to make sure my mic was on. All right, so yeah, welcome back to All This Math. If you're here, hit the like button. Go ahead, hit the like button. Go ahead. All right. Also, if you're not subscribed, subscribe to the channel. Okay. Also, when we done, share this video with at least one other person. At least one. All right, at least one. All right. And also, if you have any questions about anything we do, please put your questions or your comments in the comment section. All right, now, and also I want to give a shout out to the ancestor, Marcus Mosiah Garvey, who you see on my t-shirt here. Marcus Mosiah Garvey, born in St. Anne's Bay, Jamaica, back in 1887 in the 19th century, was the founder of the Universal Negro Improvement Association and African Communities League, also known as the UNIA, which at one point was the largest organization catering to people of African descent in the world, right? Um, did a lot, wrote, left us a lot of lessons, was a Pan-Africanist, believed in nationalism for our people, and just did a lot. Just did a lot and left a lot. Left a lot of lessons, left a lot of ideas that I highly recommend you go study. Find books on Marcus Garvey. The late scholar Tony Martin wrote several books about Marcus Garvey and the Universal Negro Improvement Association. And a lot of our scholars have done a lot of research on Garvey and the Garvey movement, what's known as the Garvey movement. So please familiarize yourself with Marcus Garvey and those that were also involved in developing the Universal Negro Improvement Association, or the UNIA. All right. Now, what are we doing today in terms of mathematics? Today, I'm making this video for my nephew Zaire, right, about comparing fractions, right, because I want him to understand how to compare fractions, and I want anybody else that's watching this video to understand how to compare fractions. And I will tell you, this is one of my favorite things to teach, and one of my favorite things to do, comparing fractions. And they're actually, when I teach this, I teach using 4 different methods, but in this video, I'm gonna just focus on 3, right? Focus on 3. What are the 3 methods? The one I call the Malcolm X method, where we cross multiply. I call it the Malcolm X method because the multiplication that we do, we go in an X formation, right? We go in 2 diagonals. We go diagonal this way and we go diagonal that way, right? We form an X. That might not look like an X, but yeah, we end up forming an X. So I call it the Malcolm X method because I like to evoke the names of our ancestors, because it's very rare we get the opportunity to do that. So I make opportunities where we can shout out our ancestors. All right. So Malcolm X method. Also, decimal conversion. We can convert each of these fractions to a decimal. And then for some people, that's easier because they can see, like, think about it like in terms of change when you go to the store, right? Or change you get back, or how much something costs when you go to the store. It's in decimal formation. So sometimes it's easier to compare decimals than it is to compare fractions. All right. And also, last but not least, LCD stands for least common denominator. Least common denominator. If we convert these fractions into equivalent fractions that have the same or a common denominator, then we can just compare the numerators. Whichever numerator is bigger, when you got the same denominator, that means that that's the bigger fraction. All right. So let's get started. Let's start with the Malcolm X method. We got 2 examples up here. I got 3/4 and I got 5/8. Now, why did I put this box here? In the box is where we'll put either the equal sign, the greater than sign, or the less than sign. And that's another lesson even in itself, because a lot of people get confused about which sign is the greater than sign, which sign is the less than sign. I'll tell you this: the open part always faces the bigger value. The open part. Yeah, like this. Some teachers call it the alligator mouth or the crocodile mouth or whatever, right? But the open part always faces the larger value, right? Now, if the values are the same, you'll have an equal sign, right? 2 horizontal bars, right? Equal sign. All right. The pointed part. So if the open part is facing the bigger value, then where's the point? What is the pointed part facing to? Obviously, the pointed part is facing to the smaller value. So pointed part faces the smaller value. Open part faces the bigger value. Open, bigger, pointed, smaller. Open, bigger, pointed, smaller. Keep that in mind. All right. Now, 3/4 and 5/8. Now, why do we call this the Malcolm X method? Because before going to X formation, right? One part of the X, the other part of the X. One part of the X, the other part of the X. In order to do this, we need to know our multiplication facts. All right. So I constantly am preaching about children, adults, everybody having multiplication facts memorized. Please memorize your multiplication facts. Memorize them through practice, right? Also, understand when you're doing multiplication, understand the relationships between different multiplication sentences. All right. So understand that 6 times 3 is going to be half of 6 times 6. All right. Keep that in mind because 3 is half of 6. Oh, excuse me. Excuse me. All right. So now, if we have our multiplication facts memorized, we know that 8 times 3 is 24. So what you do is you multiply 8 times 3, you get a product. Product is math vocabulary. The product is the value we get after we do multiplication. So our product is 24. You take that 24, you write it above the numerator that was part of that multiplication that you just did. So we did 8 times 3. The product is 24. So we put the 24 above the 3. We don't put it under the 8. We don't put it under the 8. We put it above the numerator, above the numerator, above the numerator. Then we do the same thing in the other direction. 4 times 5. 4 times 5, multiplication facts. 4 times 5 is 20. We don't write the 20 under the 4. Write the 20 above the 5. Now, we look at these two numbers, 24 and 20. 24 and 20. Ask yourself, which number is larger? Out of 24 and 20. Just focus on the products. 24 and 20. 24 and 20. 24 is bigger than 20. Since 24 is bigger than 20, that means that the fraction that the 24 is written above must be bigger than the other fraction. So that's how you use the Malcolm X method for comparing fractions. What you do is you do your cross multiplication and you look at the products, right? Wherever the bigger product is, that fraction that is hovering over, that is the bigger fraction. So therefore, 3/4 is greater than 5/8. 3/4 is greater than 5/8. Notice how I said that too. I didn't say 3/4. I didn't say 3/4. I didn't say 5/8. No, I said 3/4 because we have to understand. Let me back up. I forgot to throw this in there, right? Usually I talk about this in the beginning. What does a fraction even mean? A lot of people don't know what a fraction means. A lot of people will learn these 3 methods of comparing fractions, but fundamentally don't even know what a fraction is for real. That's a fundamental issue. So let's talk about that. What does 3/4 mean? It means you take an object, right? Any object. Could be a cake, right? Small cake, right? You divide it up into 4 equal parts. The denominator, which is the number at the bottom. Denominator, number at the bottom. Numerator at the top. Denominator tells you how many equal parts you're going to have. The denominator tells you how many equal parts you're going to have. You're going to have 4. All right? The numerator tells you how many of those 4 parts you care about, you're focused on, you're taking away, you're doing something with, right? I like to say focused on. We're focused on 3 of those 4 parts. So that's why this is 3/4. How many fourths do we have? We have 3 of them. How many fourths? 3. Object cut up into 4 equal parts. How do I know that? Because the denominators are 4. How many parts am I focused on? 3 of them. How do I know that? Because my numerators are 3. 3/4. That's how many fourths. 3 is how many fourths we got. 3 is how many fourths we got. So that's what a fraction really is. So whenever you see a fraction, whenever you encounter a fraction, I want you to interpret it that way, comprehend it that way. Think about it. Okay, what is the bottom number telling me? What is the denominator telling me? What is the numerator telling me? What's the top number telling me? Right? Right? Think about that. The bottom number tells me how many equal parts do I have altogether? How many equal parts are there altogether? The numerator tells me out of all those equal parts, how many I'm focused on. Let's look at this fraction, 5/8. This means you got an object, a cake, a pizza, or whatever, something, right? Everything's divided up into 8 equal parts. 8 equal parts divided up, right? Out of those 8 equal parts, we're focused on 5 of them. We focused on 5 of them. That's why this is called 5/8. How many eighths? 5 of them. 5/8. All right? That's what a fraction is. So whenever you see a fraction, think about what is the denominator telling you? It's telling you how many equal parts I have. What is the numerator telling you? It's telling you out of those equal parts, this is how many I'm focused on, right? How many I care about right now, right? We care about, in 3/4, we care about 3 of them. The other 1/4, we don't care about that. In this fraction, we got 5/8. We care about 5 of these eighths. The other 3/8, because 5 plus 3 is 8. And if it was 8/8, that's the whole thing. 8/8 is the whole thing. 4/4 is the whole thing. But we care about 5 of those eighths. The other 3, we don't care about them. We're not worried about them. We're not focused on them. We're focused on 5 of them. That's why this is 5/8. And 3/4 is greater than 5/8, right? And if I drew a diagram, which I'm not going to do in this particular video, I've done it in other videos on this channel, in my fractions and mixed numbers playlist, you would be able to even visualize it even better. But let's go into the second example. No, matter of fact, no, back up. Hold up. We did the Malcolm X method. We didn't do the decimal conversion. All right, decimal conversion. All right, decimal conversion. Use your calculator. A fraction also represents a division problem, right? So 3/4 is the same thing as doing 3 divided by 4, or 3 divided into 4 equal parts, right? So you go to your calculator, type in 3, then hit the division button, then type in 4, and hit the equal sign. You get 0.75. 0.75. So I'm gonna just write that somewhere. I'm gonna write that like right here, 0.75 or 0.75, right? You write that right there. That's 75 cents. Why does that make sense? A fourth is also a quarter. A fourth is also a quarter. How much money is 3/4? 3/4 is 25, 50, 75 cents. 3/4, 3 times 25 is 75. 3/4 is 75 cents. It all makes sense. All the math makes sense. Then I'm going to convert this to a decimal. I'm going to do 5 divided by 8. That's 0.625. Now, now you got to know how to round. You got to know how to round, right? You got to know how to round. You know why? Because look, check this out. Some children will look at this and say, oh, 625 is more than 75, so that's bigger. No, 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 no. You compare by place value, right? You start at the 10th place, that's a 7. And this 10th place, that's only a 6. 7 is bigger than 6, right? 7 is bigger than 6. Therefore, 0.75 is bigger than 0.625. Think about it if it was money. If it was money and we round it, make sure you know how to round numbers. I got videos on rounding numbers too. If you round to the second decimal place or the hundredths place, this 5 will make this 2 go up and turn into 0.63. So think about it. How much money which is more money, 75 cents or 63 cents? 75 cents or 63 cents? 75 cents is more money than 63 cents. Keep that in mind. All right. Now, and also don't fall for that common mistake that a lot of children make. Some adults might make this, thinking that, oh, 625 is more than 75. No, because look, what if this had 3 digits? What if we just put a 0 right here? See, now everything is balanced. So now look at it. Now it looks different now, right? Because now if you want to do it like that, okay, 750 is more than 625, right? So if you're going to compare it that way, you have to have the same amount of digits. See, now we got 1, 2, 3 compared to 1, 2, 3. If you're going to compare it that way, but if we didn't have this 0 here, that's only 2 digits. So you got to compare 2 digits. You can't compare 2 digits to 3 digits, all right? On the decimal side of the decimal point, all right? But like I said, I got videos that talk about that specifically, right? Now, this video is getting long. I was going to do 2 examples, but I'm not. I changed my mind. I'm going to do another video with this example, but I do want to show you the LCD real quick. The LCD stands for least common denominator, right? Least common denominator. So look at our 2 denominators. We got a 4 and we got an 8. The least common denominator. So you have to know something about multiples. You have to know what a multiple is. A multiple is the result you get when you multiply 2 numbers or more numbers, right? It's like a product, right? So the question is, what is the smallest number that 4 and 8 both share and can multiply into, right? Now, I'm going to tell you that it's 8. Why is it 8? It's 8 because I know that 8 times 1 is 8. And it's 8 because I know that 4 times 2 is 8. So 8 is the smallest number that they both can multiply into evenly with no remainder, nothing left over, right? 4 can multiply into 12 because 4 times 3 is 12. But 8 can't multiply into 12. So 12 couldn't be the LCD. 16 is a common denominator because 4 times 4 is 16. And 8 times 2 is 16. But that's not the L. The L stands for least. The L stands for least. What's the least common denominator? Not just the common denominator, but what's the least common denominator, right? And what's the point of finding the least, right? The point is because if the number is smaller, that makes the math easier, right? And then that prevents you from having to reduce the fraction later on. Again, another concept that we're going to get into, and I got videos on that too, where I talk about how to reduce fractions and simplify fractions. All right. So the least common denominator is going to be 8. So we want to make equivalent fractions, right? Because what you could do is, right, you could represent 3/4 in a different way with different numbers that have the same value. Different numbers that got the same value, right? That's the thing about fractions we got to understand. There are these things called equivalent fractions, right? Different numbers, but meaning overall is the same value, all right? So we can increase the number of equal parts, but still the relationship between the numerator and denominator will be the same. So this 4 turns into an 8, the 3 will turn into a 6. But why though? Why? Because what's 4 times 2? 8. So if I multiply 4 by 2, I also got to multiply 3 by 2, which gives me 6. Now I know this is a lot. I already know it's a lot. But the fortunate thing is I have specific videos that go over all of this already on the channel. I already got you covered. I got what you need. I know this is a lot. It's 3 different methods of comparing fractions that I'm going into, but I got specific videos on how to find an LCD. I got specific videos on how to reduce fractions. I got specific videos on how to round numbers. I got specific videos on decimals, right? I got specific videos just on the Malcolm X method, just on the Malcolm X method for comparing fractions. Just go into the fraction playlist and have fun. All right. Now, 5/8, I'm not going to change that because the denominator is already at 8. If the denominator is already at 8, that means the 5 not going to change. If the 8 didn't change, the 5 not going to change. So now when we have an LCD of 8 and 8, whenever your denominators are common or they're the same, all you got to do is compare the numerators. Because we're saying, okay, this fraction has this many eighths, and this fraction has this many eighths. So ask yourself, which is more? Is 6 more than 5 or is 6 less than 5? 6 is more than 5. So therefore, that's another way to know that since this was originally 3/4, 3/4 is more than 5/8. 3/4 is more than 5/8. So, like I said, we're not going to do this example because the video already ran long, right? We over 15 minutes now. Time flies when we having fun, right? But we went over 3 different methods of comparing fractions. All right. So I'm going to do another video just on these, comparing these two using these same 3 methods. All right. But make sure Malcolm X method, cross multiplication. Pick the bigger, look where the bigger number is, the bigger product is. The fraction that is near is the larger fraction. All right. Then decimal conversion. Use your calculator or do division on paper. Get a decimal, right? Decimal value. 0.75 compared to 0.625. 0.625 is not more than 0.75, right? When you compare the decimals, you should have just as many digits. You should have just as many digits when you compare the decimals. All right. So either you're going to compare 2 digits to 2 digits, and in which case this will be 0.63. And then think about like being in the store, right? Comparing the values of different candy or whatever you might be buying that costs less than $1. Is 75 cents more than 63 cents? Or is 63 cents more than 75 cents? Which is it? Right? And then with the LCD, and again, like I said, I got videos on specifically how to find LCDs, right? Because that might take a little bit to process, may take a little more time to understand. All right. What's the smallest number that both of these denominators can multiply into? And then because this 4 turned into an 8, because 8 is that number, right? Ask yourself, how did this 4 turn into an 8? Oh, I multiplied by 2. Whatever I do on the bottom, I got to do on the top. Whatever I do on the bottom, I got to do on the top. Whatever I do on the bottom, got to do on the top. So if I multiply 4 by 2, I got to multiply 3 by 2. That's where the 6 came from. The 5/8 didn't change. Why? Because it was already an 8. Think of it as doing 8 times 1 gives you 8. And then 5 times 1 gives you 5. All right? All right. So now, here we go. That's that. Make sure you like this video. Make sure you subscribe to the channel if you're not already. Drop a comment or some questions. Put some questions in the comments so I'll know what parts you didn't understand if there was a part you didn't understand. All right. And also share this video with at least one other person. And I'll catch up with you later. Peace.